Welcome to Chapter 1.4 Order of Operations lesson video. So this is order of operations, but it's order of operations focused on fractions. So being able to use fractions, being able to do order of operations problems when they involve fractions. Realistically, this is just a great fundamental math skill. This is something you're going to use in all levels of math, and it's something that a lot of people struggle with, and they don't really realize that they struggle with it until they try and do some of them. So we're going to review first some things that you can do with fractions, or the way you're supposed to do certain things with fractions, and then we'll do a couple problems that are order of operations and involving fractions. Let's go ahead and get started. All right, so the first couple things are just some important key facts that you need to know about fractions. So first of all, when we have a fraction, the top is referred to as a numerator and the bottom is referred to as the denominator. So numerator over denominator, that is what makes up a fraction. Now a couple important little tidbits, factoids about fractions. First of all, if the numerator is equal to 0, then the fraction is equal to 0. The way you should think about this is the numerator is the number of things you have, and the denominator is the number of possible things. So if you have 0 of the possible things, you have 0. But if the bottom's a 0, then it's not 0. It's what we call undefined. Now, there's a couple ways you can write undefined. You can do a circle with a slash like that. That means undefined. Or you can say like UNDF, or you can say DNE. These are all acceptable ways to write undefined. I usually write the circle with the slash. Now, the way you should think about this is the top, once again, is what you have. The bottom is the total possible. So in this case, we had 0 of something, but in this case, we have something of 0. If you had 0 of the 10 cookies, that's okay. You just ate 0 cookies. But you can't eat 10 of the 0 cookies. They don't exist, so you can't eat them. The next thing we have is we have simplifying fractions. Anytime you want to simplify a fraction, you can simplify it, but you have to be able to divide the numerator and the denominator by the same thing. So in this case over here, 12 and 20, the numerator and denominator are both divisible by 4. So we could divide those both by 4, and that would leave us with, so I'll write a little divide by 4, divide by 4, and that would leave us with a 3/5 as our simplified fraction. So as long as you can divide the top and bottom by the same thing, you can simplify a fraction. Lastly, anytime we have an integer number, so basically a number that isn't written as a fraction, we can rewrite it as a fraction by putting it over a 1. So if I give you something like a 7, you can rewrite that as a 7/1 to write it in a fraction form. Let's keep going. When it comes to adding, subtracting, multiplying, dividing fraction, these are the general rules. Addition and subtraction follow the same rules as each other. You just have to make sure if it's a negative here, if it's a subtraction and there's any distribution or something, which we might encounter later on, you do it. But otherwise, when you add or subtract fractions, the first thing you're going to need is you're going to need a common denominator. You need them to be broken up into the same size pieces in order for you to add them together. So when we have something like 3/4 plus 1/3, that doesn't work because they're not the same size pieces. One's cut into fourths, one's cut into thirds. So what we can do is we can multiply the top and bottom, the numerator and denominator, by a number to make those bottoms the same. I'm going to make the bottoms both 12 by multiplying this one by 3 on top and bottom, and this one by 4 on top and bottom. Different things will get multiplied by different values, but that's going to be the best way to do it, is by multiplying one or both of them by something to make them match. That means we're now going to have 9/12 plus 4/12. Since they're both in chunks of 12 now, we can add them together. 9 plus 4 is 13, and the denominator stays the same. That's just denoting the size of the fraction. So that's 13/12, or 13 of those little 12th size chunks. Now, a lot of times in previous math classes, you might have simplified that, rewrote it in a different form. We are going to leave it alone. 13/12 is an improper fraction, but that is A-okay in my class. All right. On the next one, when we are multiplying fractions, when you multiply fractions, you just multiply straight across. 4 times 3, 7 times 5. Numerator times numerator, denominator times denominator. 4 times 3 is going to be 12. 7 times 5 is going to be 35. Now, sometimes when you're multiplying fractions, you can pre-simplify. Say you're multiplying 2 fifths by 7/8. You can pre-simplify this. 2 and 8 are both divisible by 2. So I'm going to pre-simplify it. I'm going to divide the 2 by 2 and turn it into a 1, and divide the 8 by 2 and turn it into a 4. I'm pre-simplifying. Now I can just multiply across, and I won't have to worry about simplifying at the end of the problem. In this case, nothing pre-simplified, nothing simplified at the end, so that's my final answer. In this last example over here, when we are dividing fractions is very similar to multiplication, but there's one extra additional step. The first thing you're going to do, make sure anything that's not a fraction gets rewritten as a fraction. And then for division, your first step is to reciprocate or flip the second term. So you're going to take that second term, you're going to reciprocate it. You're going to take the top and put it on the bottom, and the bottom you're going to put on top, and then rewrite it as multiplication. So you're going to rewrite 4 fifths and multiply it by 1/3. Now this is just a multiplication problem. Now we can just multiply straight across. There's no pre-simplification. We don't have to worry about that. So we just go 4 times 1 is 4. 5 times 3 is 15. Okay, so there we go. That is adding, subtracting, multiplying, and dividing with fractions. All right, last thing we're going to talk about here is we're going to talk about the order in which we do things. And this is surprising, believe it or not, something that's a little bit challenging for a lot of people. I don't know if you guys have ever seen those Facebook posts where they put some sort of silly problem up there and everyone argues about what the right answer is. And that's because for a long time, order of operations wasn't really taught in school. It wasn't taught the same way we emphasize it now. And it caused problems. People were getting different answers for different things. So we've agreed upon this order, and this is the order we should use. So let's go ahead, let's talk about what the order of operations is. So order of operations works like this. The first thing you're going to do is you're going to execute anything inside of a parentheses. Okay, you're going to do any math that you can do inside of parentheses. You work through each of your parentheses separately. If there's nested parentheses, meaning parentheses inside of parentheses, you just work from the innermost out. So you work in to the out. Okay, the next thing you're going to do is you're going to take care of anything that's being raised to a power. So something like 2 to the third, you would evaluate that now. Anything that's being raised to a power gets taken care of at this time. Okay, the next thing that you're going to take care of is you're going to take care of multiplication and division at the same time. Okay, so when I say at the same time, that means neither has priority. Division is not lesser than multiplication, or multiplication is not greater than division. They happen at the same time. The key is that you're going to go from left to right. Okay, so if you have something like this, 5 divided by 10 times 2, you're going to do the 5 divided by 10 first. Okay, you're going left to right. It doesn't matter. It doesn't matter that I say multiplication before division. It matters that you're going in this left to right order. So you do 5 divided by 10, and then whatever that answer is, you'd multiply it by 2. Lastly, addition and subtraction, same thing. They're done at the same time. So you're going to do all your addition and subtraction stuff at the same time, executing them in a left to right fashion. So you're going to do all your addition, subtraction, left to right. If you have something like 3 plus 2 minus 5 plus 7, you start left to right. You start with the 3 plus 2, then you subtract the 5, then you add the 7. It doesn't give priority to addition, or it doesn't give priority to subtraction. You go left to right in that order. All right, so let's go ahead and see just a couple quick problems, what these are going to look like. Some of them will have fractions, some of them will not. Some will have more fractions, some will have less. Let's go ahead and give them a try. All right, so we got a handful of problems here. Some of them have parentheses, some of them do not. Some of them have exponents, some of them do not. And that's more than fine. Let's go ahead and look at our first one here. We have 4 minus 4 thirds times 5 fourths plus 11 over 6. So we're going to go in PEMDAS order. There is no parentheses. There is no exponents. So the next thing we're going to do is multiplication and division in a left to right fashion. So the first and only multiplication or division we see is this 4/3 times 5/4. Now, 4/3 times 5/4, something I talked about earlier, was pre-simplifying. Since this one has a 4 and this one has a 4, we can simplify both those 4s. Divide them both by 4, so we get 1s instead. Now we're going to go ahead and multiply, and we're going to rewrite everything here. 1 times 5 is 5. 1 times 3 is 3. And so we end up with 4 minus 5/3 plus 11 over 6. All right. The next thing we're going to do is we're going to go ahead and we are going to add and subtract in a left to right fashion. Now you'll notice a lot of people have this instinct to do the addition first. That's not the case. We go in a left to right fashion. One thing that's going to help us is, since we only have addition and subtraction left, it's going to help us to make everything have a common denominator. So I'm going to go ahead and do that. I'm going to take this 4, I'm going to put it over a 1, and I'm going to give everything a common denominator. So I'm going to multiply the 4 by a 6 on top and bottom. I'm going to multiply the 5/3 by a 2 on top and bottom. What that's going to do for me is that's going to give everything a denominator of 6. So I'm going to have 24 over 6 minus 10 over 6 plus 11 over 6. So 24 over 6 minus 10 over 6 plus 11 over 6. We can now do the addition and subtraction across the top in a left-to-right manner. So we'll go ahead and we'll do it left to right. So we'll go 24 minus 10 is 14. 14 plus 11 is 25. And so we end up with 25 over 6 as our final answer. And it's okay. That doesn't simplify. 25 is only divisible by 5. 6 is divisible by 3 and 2. So there is nothing more to simplify. Awesome. All right, let's talk about this next problem over here. So this next problem over here, one thing I want to emphasize to you is we have a parentheses, we have some exponents, some addition, some multiplication. It's kind of hard to maybe tell what to do in what order. So one thing you're going to want to pay attention to, and one thing I'm going to kind of say real quick, is this is all one exponent up here. So we can kind of put it in its own little exponent parentheses up there. So we're going to take care of each of the parentheses simplification first. So the first one's pretty easy. What's 1 plus 2? 1 plus 2 is 3. So that inside of my parentheses just becomes a 3. Now that top piece up there, that's going to have a little bit of pre-simplification we can do. The 3's, we can divide them both by 3 and make them into 1's. The 8's and the 4's, those are both divisible by 4, so we can divide the 8 by 4 and get a 2. Divide the 4 by 4 and get a 1. And we're left with 2 times 1 over 1 times 1. So we're left with 2 over 1. That simplifies a little bit further, so I can rewrite this as 3 to the 2. We've now taken care of all the parentheses simplification first. We can now move on to the next step, which would be to take care of the exponents. And in this case, we have an exponent. We have a 3 squared. 3 times 3 is 9. All right, so you could see how sometimes when we're dealing with parentheses, we end up doing some addition or multiplication and stuff first. When we're doing our parentheses, we're doing our addition multiplication inside the parentheses, it follows order of operations order. So if you had a parentheses that had something squared and added and maybe a division as well, you would take care of everything inside of here in order of operations order. So you do the exponent first, then you do the division, then you do the addition, and then you would start worrying about stuff maybe that's on the outside. All right, that should be enough to get you guys started. If you have any questions, please reach out to me in our next live session. Otherwise, I'll see you next time, and until then, I hope you have a great day.